order. And welcome to this, the Science, Innovation and Technology Select Committee's Innovation Showcase. The committee wants to understand how the UK supports innovators and what more can be done. So each week, one member of the committee selects an innovator to share their story. And this week's innovator is brought by Tom Gordon.
Thank you, Chair. So I'm really glad that we've got Suffrago here today. I am sad that Andrew can't be with us, who's one of my constituents who I've known a number of years. It's probably just worth saying that in the Selby and Ainsty by-election a couple of years ago, he actually stood as an independent and called himself the AI-powered candidate. And that's kind of probably where this sort of thing sort of stemmed from. So Suffrago are a civic tech platform aimed at strengthening the voice of everyday citizens and helping MPs better understand public opinion. With social media often drowning out meaningful conversation and traditional polling falling short, Suffrago uses AI to try and cut through that noise. Their platform gives MPs personalised constituency-specific dashboards, and it uses AI and an AI bot at the heart of their platform, which MPs can use to query data directly and get tailored insights to our constituencies. So thank you both very much for coming along today, and the floor's yours.
Thank you very much. I don't actually think we need to do anything now, Tom. Thank you. Unfortunately, our CEO, which is a really good example, suffers from various health conditions, so was unable to make it down. That's one of the things we're actually looking to try and resolve. So essentially, we, unlike the next speakers you've got, we're not scientists, we're definitely not rocket scientists, okay? So just to set the expectations, we call ourselves democracy innovators. Essentially, our core mission is to capture the real voice of people at scale, but not just the whats, it's also the whys. So what are people thinking, so that you as individual elected representatives of the constituents can see what those people are thinking and why they're thinking it, regardless actually of their political affiliation. So we are a politically neutral tech platform. We're removing the polarisation of vitriol, particularly from social media. We're using anonymity as a force for good. It's a moderated anonymity. And we're looking to give everybody a voice regardless of the political affiliation. Essentially, we're empowering individuals and their representatives and communities by blending cutting-edge tech, which is AI, and our own proprietary AI with blended into the timeless democratic principles.
And I think that one of the ways which we do that is to make sure that you don't have to have a PhD in statistics like myself to be able to understand a metric ton of data that's out there, right? So what we do is we use AI to help make it simpler, make it easy to understand, easy to digest. So more importantly, instead of focusing on the 238 million data points we have in our database, it's the 12 million insights that are actually really valuable and useful to be able to drive action and change. And what we do is we use that to mean that we can act quickly. Because as I'm sure you're all aware and all familiar with, things move quickly, times move quickly, and it's important that we're able to produce those insights in a way that means that they're still relevant by the time they need to be acted on. And that's why one of the first things we did was, as Tom so kindly mentioned, build those 650 constituency-specific dashboards. But it's not just 650, it's actually 3 times that, because we have it for income, property, crime, and there's more in our database that we haven't got, on dashboards quite yet. But it's about being able to give that information to, as Rachel said, not just be able to say, oh, this is what people are saying, but to provide context underneath it to say this is why they might be saying it.
And I guess part of why we're doing this is because we actually think the online conversation is broken, particularly around current social media. So it's polarised, and the population generally falls into 3 separate categories. And we call those the 3 Ps. There's the passionate, the passive, and the fed up, just from Hansard. And essentially, your inboxes, I take my hats off to you, your inboxes are filled primarily with individuals who are shouting the loudest and filled with vitriol. And the whole point is that also that then leads into polling, and traditional polling is also it's failing because it's due to bias sampling. So we're looking to bring those people. So I'm very active on LinkedIn. I'm not active on any other social media, only in a passive reactive form, because frankly that level of vitriol is not something I want to engage in on a daily basis. And we're looking to bring people like us who have an interest in our communities to actually engage beyond that, and so that you as their representatives become CEOs of your own constituency dashboard, regardless of whether somebody voted for you or not, with data at your own fingertips that purports directly to your own constituency on a range of different issues. And what we're doing is we're using anonymity, instead of it becoming a shield for dishonesty and trolling. We're using anonymity as a shield for good and a shield for honesty.
And how we are able to do that is, and Rachel mentioned, the traditional bias sampling and polling, where it's very difficult to get 1,500 people to reflect the mood of a national area, but we still claim that it does. What we're looking at is saying, okay, we know that we might only have this small group or this area there, but highlighting, again, as I was saying, the why they might be saying that and showing that's still valuable. And the real power in what Suffrago does is we're not a closed panel, we're not a closed ecosystem. If it's more biased in one direction, we encourage the other direction to come in and say, to have their viewpoints heard and their viewpoints said. And one of the key things that we do regarding anonymity is nobody on Suffrago will ever see how anyone's voted. That's private. Nobody else will see how Rachel commented or I commented. But we take what we view as a real responsibility for online safety very seriously. You are only anonymous on Suffrago for as long as you follow the law. If you break the law, if you act in an insightful way, if you are advocating violence, we will work with our Political Neutrality Council to then say, right, should we take action? And if we do need to take action, that information will then be passed on to relevant law enforcement. Because what we don't want to do is see a repeat of tragedies that have happened to the House, and we could have done something to stop that. So how we also then bring that in is we remove the emotion. We make sure that actually what's being said and the questions that we ask, which we crowdsource from our respondents, is reflecting the will of the people, reflecting the mood of the people. So if someone is saying something, if everyone's talking really positively about an issue, then the question on Suffrago will be positive. If it's negative, it will be negative. So we're making sure that we're reflecting what people are saying, not just what others believe they want to find out, but rather what's on the real mind of the people.
And I think we've been going only 9 months, so I'm not, but the business is very young. I'm clearly not very young. But we're already on our third iteration to make it even more intuitive, around making it more like a social media, but still with all that technology in the back. But we have also a series of what we call LDRs, local democracy reporters. There'll be one in every single constituency, so we already have, I think, in excess of 35, who again are tasked with that political neutrality. I think, though, it'd be really useful if you want to bring up some real-life examples, such as the Walthamstow transport, because this is about hyper-localisation.
Yeah, and the reports that we've generated have been used by national newspapers, global companies, charities and market research agencies. And the example Rachel was mentioning is my local MP was raising an issue regarding the accessibility of public transport inside of Walthamstow constituency. And we saw the post that was made and we thought, okay, how can we maybe support that? How can we maybe, provide context to it? So what we looked at and what we built was a report that looked at the impact of those who may be disabled or less abled inside of the constituency. And whilst Walthamstow has a actually relatively low proportion of disabled constituents, that kind of masks the data point, which is the amount of constituents who don't have access to a car who are disabled is 1.6 times higher than the rest of the UK. So in that constituency, there were 14,000 disabled residents who were going to be impacted by the lack of public transport, and we were able to bring that to the fore.
And another example, we work with MPs, we work with constituencies, we work with commercial organisations and NGOs, and one of us has just recently commissioned, and the report is still embargoed because they're working out how to use it as a charity. But in terms of the risk of death by suicide in every single constituency, that is not data that already exists. So we have gone through and using the AI and using we have in excess of 238 apparently million data points, 238 million, which actually the so what from that means that we have in excess of 20 million unique insights for these different constituencies. So all the 650 constituencies have been ranked in terms of the likelihood of death by suicide. The so what from that is that people can then start really actively campaigning and actively looking at where the mental health provision, for example, could actually kick in and from which age groups, which demographics, all that. So I guess really kind of the challenges and opportunities for us, you might have noticed we're based in the north, so we're registered in Harrogate, I live in Sheffield, Simon's from Sheffield. I am not young. I've been running tech businesses for about 20 years. There is not a particular affinity with investment into female-led businesses, and likewise Andrew is disabled, our CEO. So we have the investment challenge. We're looking for people to use as we are growing massively, and one of our challenges actually is we are almost inundated with some of your colleagues actually asking us to get involved with us at various levels, which is we accept it. We're working with people across the political spectrum.
And I think the real big thing that we need and the big challenge we have is we need people to be willing to try. There is such a there's such a sometimes reluctance to get involved with politics with a big P, as we call it. So we're making sure that it's trying to drive causes to make people willing and wanting to engage.
So it's final way as well, just because of the anonymity, we're looking to ensure that everybody actually is a verified ID. And I recently had to go through GovID to verify my director status. That would be a brilliant way, actually, we could potentially help each other, because that's a really good system. But I think in summary, we're not looking to fix broken polling, because this actually could become a polling tool as well. We're looking to build something entirely new, which we're calling the ultimate democratic platform. So big ambition, why not? We already have people in India massively interested in this as well, because obviously their system's based on ours. We are about the true voice of the people, and we're looking to scale that, but scale it responsibly. Stop asking what we think people should care about, but actually ask what they are already saying and actively listening to them, which means then that people like you, and as I said, take my hat off to you, I would love to do your job, but I wouldn't. You all went in to make a difference, and what we think is we could actually help you deliver that change. Thank you very much.
Thank you very much. Thank you very much. You do have a huge amount of ambition, but it's fantastic to hear about how AI is being used, if you like, positively to sort of to deliver on the promise of a better citizen engagement and with their elected representatives. So it's not an easy job, but thank you very much for presenting Suffraga to us and your journey, and thanks very much, Tom, for bringing them to us. And we'll look at our handouts with great interest.
Enjoy your dashboards, yes. Thank you very much.
Order.
Thank you.
Thank you.
Three, two, one. Order. And welcome to the Science, Innovation and Technology Select Committee's one-off investigation into asteroids and their detection and potential impact and why they matter. And we're going to talk about the science of detection and potentially deflection and all the other aspects of asteroids. But I just wanted to start off with a kind of an open question to each of our witnesses for this panel, which is, paint us if you like, the sort of, what are we talking about here? What's the worst case scenario if we had an asteroid impacting the Earth? Could they represent a credible threat to the human race or a substantial portion of it? And I'm going to ask Dr. Sarah Crowther to start and introduce yourself at the same time.
Yeah. Good morning. I'm Sarah Crowther. I'm a research fellow from the University of Manchester, and I work in planetary science. So my research primarily focuses on lab-based analyses of extraterrestrial materials. So that's things like pieces of meteorites, samples collected by various missions that we have here on Earth in the lab, and we can do analyses on. So in answer to your question, yes, they do pose a credible threat and could be catastrophic. The good news is that there are no known serious threats for at least the next 100 years. But, we know in the past the Earth has been hit by asteroids. The dinosaurs became extinct due to an asteroid impact. So there is potential that in the future, but, likely the distant future in terms of our lifetimes, something could happen.
Great, thank you very much. And Professor Chris Lintott.
Good morning, everyone. I'm Chris Lintott. I'm a professor of astrophysics at the University of Oxford, though currently talking to you from a borrowed office at the University of Warwick, where I'm filming for the BBC Sky at Night programme today. My involvement in the subject is that I am an observational astronomer. I play with telescopes and particularly large surveys designed to conduct a census of what's out there, and that includes discovering populations of asteroids, and in particular asteroids that might threaten the Earth. My own work is on interstellar objects, so asteroids from other solar systems, which are unlikely to pose a threat. To add to what Sarah said, I think there are a couple of characteristics of the asteroid threat that make it unusual. The first one is that the impact of a very large impact would be very large. We're talking about something that could threaten life on the planet or indeed our civilization, though we think that things large enough to do that hit only once every tens or hundreds of millions of years. So we have a high risk, but a low probability. And our systems of thinking about risk are rather poor about doing anything about that. The second thing that I think is unusual is this is a natural disaster that we can do something about with new technologies, as we'll discuss today, I hope. We're beginning to get the hang of dealing with this threat. And so this may be a risk that we'll be able to retire in the next 20 to 30 years or so.
Thank you very much. So we are, as you say, talking about something which is a high risk but a low probability. Just to put that a little bit more in context, so you mentioned the extinction of the dinosaurs, Dr. Sarah Crowther. How long ago did that happen? And so if we're talking about a sort of existential threat event every, did you say 10 million years or so? Sorry?
66. Yeah, I forget exactly when the dinosaurs, when that impact was. 60 million
I'm told
years?
it was 66 million years ago. So if we're talking about a one in tens of millions of years threat, haven't we gone tens of millions of years since the last one? And if is it also the case that there may be bodies outside of the solar system which could hit the Earth and which we would have less knowledge of?
Yeah, so there's a really nice summary graphic that NASA have produced that I can share with you after that summarises the different sizes of asteroids, how many there are, how frequently they're likely to hit the Earth, and what sort of impact they do. But according to their numbers, we're talking about something that could cause global devastation, I think about roughly once every 500,000 years. So yes, we have gone further than that, but that's probability, isn't it? Just because that's the probability, it doesn't mean it absolutely will happen. In terms of things from outside our solar system, I think that's more Chris's field than mine.
Okay, thanks very
much. Yes, interstellar objects are rare enough that we don't have to fear those. It's mostly asteroids. So maybe we should set the scene geographically a bit. So most asteroids in the solar system exist in the asteroid belt, which is between Mars and Jupiter, but they become disrupted, usually by encounters with either of those planets, and they can move into orbits that cross the Earth, and then it's just a case of whether we're in the wrong place at the wrong time. It's the smaller asteroids that happen to hit us more frequently. So, for example, something about 5 or 6 meters across, something that if it hit the Earth would cause an explosion about the same as that with the nuclear device dropped on Hiroshima. Those impact the Earth about once every 5 years. And I think that number's shockingly high if you haven't heard it before. But that's because most of the Earth is ocean, of course. So we don't see those impacts, and there hasn't been an impact that's caused a death. But that gives you a sort of baseline threat from these things. Bigger asteroids, which are about 50, 60 meters across, which in the slightly disturbing jargon of the people who work in this area, they tend to call city killer asteroids, enough to threaten whatever it landed on, and perhaps to require evacuation if we could predict it and so on. Those hit, numbers are a little difficult, but maybe between every few hundred years and a few thousand years. And so a lot of the attention has been on trying to discover whether we can detect the population of things at that size and then do something about them if we knew, for example, that there was going to be an impact in a decade or in 20 years' time.
Thank you. And indeed, towards the end of last year, a near-Earth asteroid YR4 was detected in December, and I think the initial concern was that there was a 1% chance of it hitting the Earth, which to me sounds very, very large. And indeed, the fact that there was an asteroid, a city killer asteroid hitting the Earth every 5 years, as you say, it sounds quite very concerning. That YR4 is no longer thought so likely of hitting the Earth, but it is thought that it might hit the Moon. What kind of impact might that have on?
I can start on that. So YR4 was a really interesting test case. It's the first time that we've had a substantial asteroid. It's about 50 meters across, where we had, as you say, a few percent chance of it hitting the Earth. It was discovered in December, and further observations, which help us refine the orbit, so to predict where it's going to be in the years to come, raise that probability up to about 3% before observation showed definitively that it will not hit the Earth in the next few decades. There is currently a 4% chance that on the 22nd of December 2032, it will hit the lunar surface. And you may have seen there's some press coverage of a new paper out in the last couple of days that looks at secondary impact. So it hits the moon, bits of the moon fly into space. If this thing does hit the moon, it would create a crater about 1 kilometer across, as well as great excitement for astronomers who've longed to see this process in action. But the debris from the moon, there's some small chance, and I think it really is in the low hundredths of a percent, that some of that debris may end up impacting the Earth. And while that wouldn't impact us on the surface, there are threats to satellites. And so I think there are two things to draw from the YR4 story. One is that the system worked. We detected it. We detected it with nearly a decade's notice, and international follow-up observations were quickly coordinated to allow us to determine what the impact or what the risk was. The second thing is this story about whether it hits the moon and so on shows that there are nonlinear effects here, that we can't predict exactly what's going to happen across what is quite a complex system. And so continued calculations of vigilance are also needed.
Thank you very much. I think we'll get into more of the detail of that complex system now. Kit, would you like to?
Very much, yeah. I was going to ask a little bit more about YR4, but just on what you said previously, you said that I think, did I hear right? You said that a 5 to 6 meter across asteroid hits the Earth on average once every 5 years. But so these are plunging into the ocean, Professor, and we're just sort of not observing them. But
that's right. We're very bad at. Yeah. Sorry,
if a nuclear bomb is dropped into the ocean, you kind of would spot it. So, are they? Is it really that frequent? That sounds quite frequent to me.
Well, yes, it's the effect of the atmosphere as well. So as we'll go on to talk about, Sarah's expertise in the composition of these things is crucial, because whether these things are stony, made of iron, rubble piles, will make a big difference. And so going from size to size of impact is rather difficult. But it is true that we see, based on the population that we see encountering Earth, that's about the right number, that things about 5 meters across hit every 5 years or so. And the most recent example of damage being caused was an impact called Tunguska in Siberia in 1908, where luckily uninhabited area, but trees were knocked down over quite a substantial radius, hundreds of miles from the impact site. And that impact, for example, is believed to have been an airburst, something that exploded in the atmosphere. So we do see evidence of these things in the historical record, but we have been lucky, I think, in the last 50 years that we haven't had a substantial impact on land.
Well, that was going to be my next question about that. What that says about the probability of it hitting the land. So you combine the once every 5 year incident with the fact that the Earth is whatever it is.
2/3 water.
2/3 water. What is the likely frequency of an asteroid that size? And I've seen the pictures of the one in 1908, which are pretty huge, the impact. What is the likelihood? How often can we expect one of those to hit land?
I think it's every few decades. And you'll think back to, there was a 2012 impact in a place called Chelyabinsk, by coincidence also in Siberia, where there were about 500 injuries, mostly from a blast that shattered windows and so on. There's some a lot of footage of that from dash cams and from amateur recordings that showed the kind of impact this would have if it came in over a city. So there is some risk here.
And then the final question, just in this section, if I can, is obviously our primary concern is about asteroids hitting the Earth and there being and you've talked about YR4 hitting the Moon and there being possible impacts. Should we be concerned about a significant impact on the Moon affecting its relationship orbitally with the Earth, and therefore it's a good question, and calculations have been done for YR4, but the difference in size between even the largest asteroids that cross the Earth's orbit and the Moon mean that system won't change. So if say, forgive me, Professor, but if say an asteroid, a kind of city killer size, was heading towards the Moon, and was therefore going to impact on the Moon, would that have the potential to divert its orbit, and that therefore have devastating impact, for example, on the tides and all the rest of it in the UK?
No. The Moon gets hit by these things reasonably frequently with no change to its orbit. So you'd get some excited astronomers, and we'd have to worry about the secondary risk. But there's no change to the lunar orbit.
Okay. And then final question, if I may: how much of a shield for the Earth is the Moon?
That's a very good question. Yes, it is true that because the Moon exists, we get hit much less frequently. It's about 60% less frequently. Wow. People have used this theoretically to argue, for example, that if we look for life elsewhere in the universe, we should look for planets with large moons so that they have a similar protective power. So we should be grateful that it's there.
So the presence of the Moon reduces the probability even further of something hitting it?
That is included in the numbers that I've given you.
Right.
So without the Moon, you could increase those. Our solar system also benefits from Jupiter, which does quite a good job of removing asteroids from the solar system when they encounter it.
That's fascinating to understand the planetary impacts, as it were, on protecting our planet.
Well, it's not just that, to be honest with you. It's an interesting theory about the evolution of life on Earth. Yes, part of the coincidence is the alignment of the planets and the Moon. Not least the effect of the Moon on tides meant that organisms within the sea found a way of existing because they had to, because of the movement of the tides. But anyway, another day, the theory of life on Earth. And its random nature.
All human life is in the select committee. And now I'm going to ask Emily to continue.
So just before I move on to how we measure all of this and what amazing bits of kit you guys get to play with, so the Moon attracts the asteroids, because of a gravitational pull?
Yes, but it also literally just gets in the way.
Because it's going so frequently around.
Yeah, but it's not that fast.
No, it's so you have to think about, so if you imagine a near-Earth asteroid on an orbit that crosses the Earth's orbit, so every time it comes round, there's a chance that we get in the way. There's also a chance that the Moon gets in the way. And so it ends up taking about half the impacts that we would otherwise suffer.
But it's just interesting because the Moon is smaller and it gets hit more frequently than we do. So there must be something different about the Moon than ourselves.
There is a detailed study which I could share, which is an event called gravitational focusing, which means that you're more likely to hit such an object. I believe there's a fire alarm test happening in the background, by the way, if you can hear an alarm, so apologies for that.
So I wanted to get a little bit and nerd out a little bit on all your kit that you guys use to really understand this. Maybe we'll start with Sarah. In terms of how are we placed in terms of science and kit in the UK, and what kind of kit is that, and what kind of scientists are we talking about?
Analysing the asteroid samples, whether those be meteorites or samples that have been returned by missions like the NASA OSIRIS-REx mission or the Japanese Hayabusa missions. We're in a really good position, and we have had researchers who've been part of the mission teams for those 3 asteroid sample return missions. We study them in exactly the same way that we would study terrestrial rocks. So many planetary science researchers are based in geology or earth science departments. And we use the same techniques. We just have to remember that the material is limited. If you're studying something about volcanoes or other rocks on Earth, you can go and collect bucket loads of it and study as much of that as you want. If we're studying samples from asteroids, we may only have a few milligrams. That might be all there is for a particular meteorite sample. So we have to use techniques that are really sensitive so that we can get the most information possible out of the smallest amount of material. So people use techniques like microscopes, electron microscopes in particular, to look at what the material's made of, what minerals and things are there. We use mass spectrometers to look at their chemical compositions, from which we can do things like work out histories, date how old the rocks are, work out their histories, whether they come from an asteroid that's what we call a rubble pile, which means it may have been a large single rock originally, but at some point in its history, it's got broken up and then just kind of loosely reconsolidated under its own gravity. So in particular, looking at my research, I just study the noble gases in the meteorites. So we use very sensitive mass spectrometers to measure the noble gases. And in fact, the one I use at the University of Manchester is unique. It's the only instrument of its type worldwide.
Fantastic. So what does it tell you, not just about the meteor, but does it tell you anything about life on Earth or life potentially elsewhere in the universe?
Yes and no. No, because we have never found any evidence of life anywhere else in the solar system. But we believe that some of the asteroids delivered the key ingredients for life to Earth. There's a particular type of material that we call carbonaceous chondrite that's rich in organic compounds, water, volatile compounds and species, all of which are essential key ingredients for life. And we believe that those ingredients were delivered to Earth by asteroids in the early solar system. And in particular, recent analyses of the samples from asteroid Bennu, which were collected by NASA's OSIRIS-REx mission, have found that it contained the conditions where the key building blocks of life were produced. So they found evidence of all the amino acids that are used by proteins, as well as the nuclear bases of DNA and RNA in the Bennu samples. So those are the key building blocks of life that may have been, we think, were delivered to Earth by asteroids.
Wow. Very fascinating.
I just why are they on the asteroids and not on the Earth to begin with?
Well, that's a good question. I guess some of the asteroids, so early in the solar system's history, the Earth melted and it formed a metal core and a rocky surface that we're stood on. So that meant that all the building blocks of the original Earth got mixed up together and their signatures got lost. So they may have been there, but their signatures may have got lost in that early processing. But some of the asteroids never got hot and melted, so they're kind of like time capsules from the beginning of the solar system, and we can see like the very first solid materials that formed in the solar system in those asteroids. And I brought a couple of examples if people would like to have a look at them, and one of them you can particularly see
We want to see the origin of the universe.
solids that formed in the solar system.
Just going to follow up to Emily's question. Why is this unique spectrometer in Manchester?
Well, that would be down to my boss. So the research group at the time in Manchester originated at Sheffield University, and some of the original work that Professor Grenville Turner did was dating the Apollo samples. He was one of the first people to get Apollo samples and one of the first people to determine ages for them. I think it was in the mid-80s, the group moved to Manchester University, and my current boss, Professor Jamie Gilmore, took over that instrument that they'd started developing in Sheffield.
So this is a UK...
I'm sorry to interrupt, but does the world then flock to your door to use this instrument?
I'm not sure flock's the word, but we do have international collaborators who will come to use the instrument because we can do analyses on really tiny samples that couldn't be done anywhere else in the world.
That's a really fascinating and quite inspiring example of investment following excellence and then leading to more scientific and research excellence. Right, but back, interesting journey, but back to Emily.
No, I mean, absolutely fascinating. And just to say, you know, Dr. Sarah, you have now made me think about the probability of asteroids hitting other planets that may bring
Time capsules. hitting
the
other
little time
planets.
capsules to them.
Yeah.
And even if there isn't life there yet, there could be life then created.
Yeah, and we can see examples of asteroids hitting other planets. The Martian rovers have seen meteorites made of metal on the surface of Mars, and we've got pictures of those from the Martian rovers. I forget exactly which one. So we know that meteorites have hit other planets. So yes, in principle, they could have delivered those key ingredients, but you also need the conditions where those ingredients can flourish and then ultimately produce life. Because they didn't deliver life, it was just those ingredients, and having the ingredients doesn't necessarily lead to life.
Yeah. No, it's fantastic. So, Professor Chris, quite similar question. What is the kit that you're using to spot these asteroids? And how are you measuring their trajectory? How are you understanding their composition before they hit the Earth, if that's possible, or predicting it? And also, where are the UK strengths in that?
Yeah, this is a very good day to be asking this question because yesterday we had the first images released from a telescope called the Vera Rubin Observatory, which is in Chile and is an American facility with substantial contributions from all of the UK's astronomers to operations. So we're a major part of this survey. One of the reasons to build this telescope is that it has a huge field of view. It covers a large part of the sky at once, and it will be brilliant at spotting these asteroids. So we're predicting that in the course of the survey, which is the next 10 years, starting in the next month or so, we should find about 180,000 near-Earth asteroids, so those that cross the Earth. So that's an increase on the current number of about 35,000. So we'll have found about 70 to 80% of everything that's 150 meters and higher. So this is the technology that will give us a census of things that might hit the Earth. So that's discovery, where here in the UK, I think we're playing a really leading role through colleagues at Queen's University Belfast, in Edinburgh, and many other institutions. So we now have this new tool for discovery. Follow-up is globalized. So as soon as one of these things is discovered and seen to be potentially a threat, then pretty much every telescope on the planet moves, including the European the European Southern Observatory, to which the UK is a major contributor. So there too, we can look at. At this point, it's about, we only ever see these things as points of light that are moving. So what we can do is we can work out their orbit, we can work out their color, and the color tells you sometimes what they're made of. So that's the first clue whether these are stony meteorites or, like the Bennu, which OSIRIS-REx explored, a rubble pile. And distinguishing those is very important if we get to thinking about intervention of stopping these things hitting. And then we might see them changing in brightness, and so that gives us an idea of shape as well as size. So the astronomy piece of this is a strength. And then, as Sarah has talked about, we have world-leading expertise on the ground studying existing samples of meteorites that have come to Earth. I would say where we're less strong compared to some of our competitors is in the observational study of these objects while they're in space. Other countries have invested, for example, in radar systems that can, for very near-Earth asteroids, give you a shape and a size definitively, which is crucial for near-Earth asteroids, or at the study of the particular populations that might impact the Earth, which is not something that we've typically invested in this country.
And when you say near Earth, it'll be able to detect near Earth. How far away in sort of years is
yeah,
near
my
Earth?
apologies. Yeah, near Earth means has an orbit which crosses our own. So that's a potential impact.
Days away?
So near Earth.
Away?
Sorry?
Days away or years away or?
So we would want to discover these years away for sure. So the idea is that in the next few years, with Vera Rubin playing a major role, we would like to be able to have a complete census of everything that's 150 meters or more across, and then we can predict for about a decade how these things will move based on current technology and data. So that would give us maybe 5 to 10 years warning of any impact of something that large. That's the timescale on which we think, we haven't yet mentioned the recent DART mission, which carried out a test of impacting an asteroid and deflecting it. We think something like a 5 to 10 year timescale would allow a deflection mission to take place if the space agencies of the world were able to coordinate such a thing.
That's probably a pretty good place then to hand over to Kit, because I know he's got dark questions.
I was going to ask Dart on the second panel, but I did have a question for you, Professor, about the predictability, if I may, just on the following Emily. Is it feasible that some massive chunk of rock could come slicing through the universe at enormous speed, effectively evade the gravitational pull of the various planets and the sun, and slam straight into us, and what kind of speed notice will we be talking about? Because my assumption is there are these things, winging across the universe that are so large and so fast that there's not a lot that the planets can do to deviate the course. Is that?
Yeah, so this is one of the things that we want to investigate with the Vera Rubin Observatory, these interstellar objects, where we don't really know what the flux may be, but the thing you have to bear in mind is that space is incredibly large, which sounds like a silly thing, but it's actually fundamental in the odds of anything coming from beyond the solar system scoring a direct hit on the first pass through the solar system on the Earth are minuscule. The background threat from asteroids in the solar system, which far outweighs anything from beyond. So we should worry about things in the solar system first. I think where we have blind spots are asteroids that are coming on orbits that head towards Earth from the direction where the sun happens to be. We obviously can't search for asteroids close to the sun. And one of the solutions to that is to switch from optical telescopes that use the kind of light that our eyes are sensitive to infrared telescopes, which could do a better job of spotting asteroids wherever they are in their orbits. There's an American mission called NEO-SURVEYOR, which is a space telescope that will contribute to this and will sort of complete our census. That's due for launch in 2027, but is obviously subject to, let's say, current uncertainties in US budgeting.
US funding. Yeah.
And that is a place where we are entirely reliant on the US. No one else has any plans to do an infrared survey of this sort.
Just to follow up on that, because we're trying to get an idea of the risk. You talked about being able to identify, I think, up to 90% of NEOs larger than Neo-Earth objects larger than 140 meters, which is very big and a huge risk. But that still leaves. So your expectation is that will still leave 10% of them unidentified and unrecognized. And have you got an idea of how many that is?
Yes, we think that would be about 20 to 30,000 if our estimates of the population are correct. That is based on a 10-year Rubin survey with this new Vera Rubin telescope. That's the current plan. It's been shown that by extending the survey, one could do better than that. And I think another aspect of this that's hard to understand is that we can't. There's a sense, I think, that astronomers are good at this, that when we find something, we'll know its orbit forever. But actually, the push and pull of the gravitational attractions of the other planets means it's very hard to predict these things a long way in advance. The sun and sunlight has an effect on these asteroids as well. So we will need continual monitoring, even after the end of the survey, to keep track of these things and to assess any risk that we find.
And is there a concern, you sort of suggested, I think diplomatically, a concern regarding funding in the US for programs. Can you say a little bit more about that?
Yeah, I think in general in this area, we've depended on a small number of crucial facilities. So I mentioned the NEO Surveyor mission. Vera Rubin, though now successfully funded, thanks in particular to support from UKRI, is playing a vital role. But for example, we lost recently the capabilities of the Arecibo radio telescope in Puerto Rico, which was the main facility that was doing radar work. So when one of these asteroids comes near the Earth, you can use radar to get a sense of its size and shape and composition. Arecibo collapsed a few years ago, and it has not been replaced. And it's an example where we've been relying on a single country to fund infrastructure that forms part of planetary defense that helps us all understand the threat from these things. So I am concerned that funding is always dependent on national priorities in this area for what should be and will need to be an international effort if we ever did discover something that was threatening.
We recognise that concern. That's the concern around public sector funding. Now, there is commercial interest in asteroids, and to what extent do asteroids matter in terms of their potential sort of an opportunity for commercial mining?
Well, maybe Sarah could talk first about the kind of things that we might find in the asteroid population that we'd want to mine, and then we can both perhaps speculate on the possibilities.
Yeah, so we know that some of the asteroids are rich in metals. So one of the pieces of meteorite that's been passed around, you'll have noticed, was basically a lump of iron. And metals like that on Earth are generally in the core. The amount of metals in the crust are quite rare. So mining, particularly some of the precious metals that we're so reliant on for technology, phones, computers, etc., mining those on Earth is difficult, and there's a limited supply of them. In some of the asteroids, there are relatively high concentrations of metal, which may have been in a core like that meteorite that I passed around, but that's since broken up, so it's more easily accessible in the asteroid. And some of the other asteroids that never got hot and melted, you can still see the metal mixed up among the rocky material. So the metals are there, and in particular the precious metals are there, but I think the technology to mine them is still a long, long way off. We sent people to the moon in the 1960s and 70s. We've not progressed beyond there. In fact, right now, we can't even do that. So I think the technology advances we need to actually be able to mine asteroids and to make that financially viable is still a long, long way off.
I'm going to go to Martin and then to Lauren.
I'm glad you mentioned that, because looking at this piece that you passed around, it seems remarkably pure metal. And it may be a mix of metals, but I'm surprised it's not sort of like an iron ore as opposed to that. So why is it real metal and not an ore?
So that is predominantly iron with a little bit of nickel in it, and you might have noticed it's kind of got some crisscrossy patterns on it. They're real, that's not scratches or something, that's two minerals containing iron and nickel, two different minerals that have crystallised out. It's pure metal because it came from the core of an asteroid that got hot and melted, so then the metal's heavy and it sank to the middle and formed the core, exactly as happened on Earth. And the lighter rocky material rose to the surface. It then cooled down, became solid, and at some point in the solar system's history it's broken up, probably due to an impact with another asteroid.
It's fascinating. Lauren?
Wow, no, this is really, really exciting. I'm so grateful that you guys are here. Just sort of building on the kind of the threat of funding and for these international programs and things, and just looking into the future, can you imagine a place where who would own those asteroids for that mining space, and where do you think we need to be in a kind of a world view of that?
So there is already some, I'm going to call it space law, which I don't know the details of, but there is a UN office for space law, and there's a UK Space Act from, I made a note of it because I'd forget, 1960 something. No, I didn't make a note of it, sorry. There's a UK Space Act from 1960 something. But the gist of the UN law is that nobody owns objects in space, and they must be used for the benefit of all countries and all mankind. So we couldn't, for example, lay claim to the moon or to a particular asteroid or something. So if it got to the stage of mining, that's going to be tricky, and I don't know how that would work out.
So maybe I could just there have been a couple of commercial companies that were established about a decade ago with the aim of carrying out test asteroid mining. None of them got very far because of the cost of access to space, though that's a field that's evolving rapidly. The argument used at the time was that, as Sarah says, the Outer Space Treaty requires anything in space to be used for the benefit of mankind. But the argument was that there was case law, or at least an accepted practice, that countries that had gone to the moon and returned samples had made use of them as they like without any regard to this proposition. So the argument was that asteroid mining would be fair game under the treaty. You'd need a lawyer or perhaps your next panel to disentangle. I will point out there is a slight problem with the economics of all of this as well. For example, it's been stated that one of the asteroids, the one we might want to go, is particularly rich in platinum. You'd certainly have enough platinum to make money, except that there's so much platinum in one of these asteroids that you'd instantly collapse the price of platinum here on Earth. And so there is an economic problem here. One place where asteroid mining is often talked about is in terms of resources. If we're in a situation where there is more space flight out into the outer solar system towards Mars, perhaps even further, that sort of science fiction scenario, one often thinks that the asteroids are providing stuff like water that one might need, both for rocket fuel and for human consumption. But for that sort of scenario, we need to be in a world in which the cost of just getting stuff off Earth is dramatically reduced. Now, some of the people who work in commercial spaceflight will tell us that we're heading rapidly towards that world. I'm still reasonably skeptical, and I suspect that this will remain a science fiction thing for at least the next 30, 40 years or so.
So off the back of that kind of science fiction and engaging with the public, I mean, this is a topic that captures everybody's imagination. So, Professor Chris, would you be able to tell us a bit more about your Zooniverse that you launched back in 2008 and how that has really helped science?
I can, and perhaps I can talk more generally about citizen science, because astronomy, and in particular this study of small bodies in the solar system, has been an area where the public have contributed. So Zooniverse, which we run in Oxford with collaborators, is a platform for what we call citizen science. So people can log on and take part in about 200 projects, from classifying galaxies to discovering planets to a whole host of non-astronomical things. The relevant piece is that we have a partnership. In fact, Zooniverse is part of the UK's contribution to this Vera Rubin Observatory project. So we've used it as part of our buy-in to get access to the data. And we'll be asking volunteers to look through the data released by Telescope, and in particular to keep an eye on asteroids for signs of activity, to see if they are becoming comet-like. It's a clue to composition and how they evolve. But there are other aspects here. There are several amateur observatories in the UK who contribute to the follow-up of minor planets, and who contribute to the international effort to track these things. And I want to highlight in particular the UK Fireball Alliance, who are placing cameras around the country, particularly working with schools, to look for meteorites that might be landing in Britain. Nothing threatening, but in an effort to discover, to connect what we see in the sky to things that land here on Earth, and then be able to close that loop as well.
Wow.
That is fascinating, and I suppose we haven't really talked about the number of asteroids that do land without doing any damage, but could be picked up and identified by school children. Is that a significant number?
We get, Sarah will probably know the numbers. We get a lot of small things hitting the Earth all the time. Most of them, of course, burn up in the atmosphere. We did have a famous fall in the UK in Winchcombe, in the Cotswolds, a couple of years ago, which produced a magnificent carbonaceous chondrite, a type of asteroid that's particularly old, and tells us about the formation of the solar system, and samples from that are now on display at the Natural History Museum and indeed in Winchcombe. So if we could do more of that, then we want to be able to go from seeing something in the sky to connecting to the composition, sort of connecting my world and Sarah's, the dot that you see in the telescope with the thing that you have in the lab. And if we can find more samples as they land, that will help with that effort.
Yeah.
Okay,
I just a couple of follow-up questions. First of all, Dr. Crowther, we talked about beneficial materials. Is it possible that something could hit the Earth that has something really unpleasant on it? Kind of isotopes, or I don't know, polonium-210 lands and spreads, or could something unpleasant be on one of these things?
Not to the very best of our knowledge, no. They're made up of all the same elements that we have on Earth. There's no elements in the asteroids that we don't have on Earth. Some of the minerals are a bit different because what mineral forms from a combination of elements depends on things like temperature and pressure. And the ratios of isotopes, so the different types of a particular element, can vary. But there's nothing dangerous about them. People often think they're going to be radioactive, but they're not. I mean, they do contain the remnants of radioactive elements that were around in the early solar system, but that's how we can date them. That's how we can determine how old they are. There's nothing harmful to us in them. And when you see pictures of people handling these samples in their white suits,
Yes.
Or working in a glove box, that's to protect the sample from the people, not the people from the sample.
Right, okay.
We don't want to get our greasy fingers on it or sneeze on it. Or
Right, and
whatever
are you
it is.
able to detect at a distance the levels of radioactivity in these things? I mean, when it's winging its way toward Earth, will your instruments allow you to detect?
I don't know that, but they're not,
The
they're
colour,
not
I think,
radioactive.
Professor, the colour will tell you something about its composition, but is there any other metrology that allows you to...
In theory, if we could get spectra, we have some sense, but we're really talking about broad categories. I think we would know if something was very unusual because we've connected the common things that we see, asteroids of particular colors and spectral types, to meteorites that we have on Earth. So most of them are fairly well categorized. If there was something really spectacularly unusual of the type that you're saying, I think it would stand out. Whether we know why it was standing out or not, I don't know. We did do the fun project a few years ago when Elon Musk launched a car towards Mars as a test of one of his rockets. We did check that the car stood out in our data and we were able to distinguish it from the natural background population, which sounds silly, but it does give us a sense that we would spot anomalies. So I think we know that there was something unusual about a particular system, but we wouldn't necessarily know what it was.
Thank you very...
Sorry, I just had one more question. Just the public, just before we finish up, the public aren't very good at understanding probability. It's why we have a national lottery, right? But could you give us a kind of illustration of size and probability? So if the known universe that you're examining is a football pitch, what are we on that football pitch? Are we an atom? Are we a ladybird? Are we a football? What kind of comparative size are we?
I think that's quite a difficult question in this context because everything is moving. So we are a tiny fraction of the solar system. So I think if you take your football pitch analogy and we say put the orbit of Neptune around the edge of the pitch, then we are something like a peppercorn a few centimeters from the center spot. Right. So that gives you the scale, I think. So this space is big, I said earlier, which may not be the most profound thing ever said to a select committee, but I think it's important here. Yeah. And that's why but I do want to comment on your point that the public, and indeed all of us as humans, we're badly wired to think about probability. And I am worried, the 2024 YR4 was a great news story because the papers could update each day with the new percentage of whether this thing might impact or not. But I don't think we're very well equipped to talk about a 3% risk of impact. If I tell you there's a 97% chance of a pay rise, then most people have gone and spent that money already. If I tell you there's a 3% chance that you're very ill, then you take that very seriously. And I think we're going to need, as we find more of these things, and maybe we live in a world where there's always an asteroid that has a 1% chance of hitting us because it's just been discovered and the processes are playing out. We're going to need to find, I think, a better way of talking about these things.
Well, I think that's exactly what Tom is going to lead us off on now.
Yes. Thank you, Chair. We've all seen big Hollywood takes on movies around asteroid threats, from Armageddon, which I can remember watching fondly when I was a little kid, to more recently to, sorry to make anyone feel old there, from Don't Look Up, which was only a few years old. Are such films helpful in raising awareness, or do they end up tipping people over the edge, panic buying and bunkering down?
Shall I go for it? Yeah.
Go to
Sarah?
Get to Sarah first.
I haven't actually seen Don't Look Up, but I have seen Armageddon. Yes. I think it's a mix. I think you've got to allow people a bit of storytelling to make a good film or a good TV show or whatever. So these things often have a basis, a background of true science, but they've got to embellish a bit to tell a story. And personally, as long as it's kind of vaguely believable that this might happen in the future, I don't have a problem with that. But I know some people get very wound up about picking apart everything that's wrong with these movies. I'd say from my point of view, if these types of movies or TV shows are getting people, and particularly young people and children, interested to then pursue studying science and potentially a career as a scientist, then they're really important.
Okay, great. And Professor Lindsay?
Well, I'm tempted to repeat a remark from a colleague, which was that the most unrealistic thing about Don't Look Up is that the senior professor does the calculations himself instead of getting students to do it for him. So obviously there's some work to be done. And I think they are useful in raising a broad understanding of the topic. I do think there's one thing that's dangerous about the stories that they tell. I understand why it's done from a storytelling perspective, and that is that these things are always handled at the level of shady government organizations. You know, the astronomer picks up a phone and then the government or the military turn up and then it's secret. And there's always this big discussion about who to tell when. And actually, I think the one thing I'd want to get across to the public is that this has to operate in the opposite way, because long before we know that an asteroid is the kind of threat that we'd want to bother a government with, we've had to coordinate observations around the world with other astronomers. And so a realistic version of these films is always going to have things playing out in public. And I think that's a really important message to get across, because that's where we build trust, I think. Anyone can go to the web pages maintained by the European Space Agency or NASA and look at the current list of known asteroids and the threats that we think that exist. And I think if these films portray a secretive world, then I think they are doing some damage, even if it makes for better stories.
Great, thank you very much. And a follow-up for that, Professor. There's a quote in the film, Don't Look Up, from Meryl Streep's fantastic Trump-esque president character, where she says, "I hear there's an asteroid or a comet or something that you don't like the looks of. Tell me about it, and then tell me why you're telling me about it." So I wondered, just with that in mind, if you'd be able to explain a little bit more about the role communicators such as yourself play in engaging with the public when it comes to asteroids and planetary science.
Yeah, thank you. It's 2024 YR4 was a really good example of this, because there is this strong public interest. I think people know that this is a threat and they want to understand it. And I think our role is twofold. I think one is translating what we've seen in this committee discussion can become a discussion that's full of numbers and full of probabilities and can get quite technical quite quickly into statements that people can use, essentially. Should I worry about this over my cornflakes or not? And I think we can do that. The second thing is, I think this is a place, and one of the reasons I like and I moved to work a little in this area, is that I think it's a really good place where we can communicate, particularly to young people who are considering a career in STEM or in science, that this is a place where discoveries are being made. This isn't textbook science. This is stuff that's changing really rapidly. And so I think we can use the hook of, the asteroid that did for the dinosaurs to talk about the wonderful science that Sarah and colleagues are doing and the potential of discovery from telescopes like Rubin. So these are good stories for us to tell.
Great, thank you. Is there anything that you want to add to all on that?
I guess the kind of public engagement work I do is a bit different to Chris's, but we do a range of sort of family science fair type events. And what I see as really important is engaging the children and the parents with them so that the parents are interested. You know, just to inspire the next generation of children who might go on and make that fantastic discovery or might stop that asteroid that's going to be a threat in the future. I think we've got a great topic because, you know, we go to these events with those meteorites and more, and you offer people the chance to hold them, and you can get their interest and engagement really easily. The difficulty is maintaining that. And by no means meaning to criticise schools and teachers. You know, schools have a very prescriptive science curriculum. They have to do chemistry, physics, biology, which are very distinct and separate subjects in how they're taught. And it doesn't really give the opportunity for all the places those overlap or all the topics where, all the fields where you're using those sciences but not studying them directly. So trying to get young people and children to be aware that these are things that they can study in the future is really important.
Yeah, thank you very much. And then the final one from me is, again, with another quote from Don't Look Up. You cannot go around telling people there's a 100% chance they're going to die. So to what extent can rare event statistical modelling, such as those predicting a 1% likelihood scenario, be effectively communicated to the wider public? And how does it affect the understanding and decision-making in the event of an asteroid threat?
It's difficult, but I think we talk about specific examples. I think the abstract threat is very hard, but I think the story of YR4 is compelling. I think the story of Bennu is compelling. We have the UN has designated 2029 the International Year of Planetary Defense, timed with the close approach of an asteroid called Apheophis, which will swing only 30,000 kilometers away and will be visible to the naked eye from the UK as it goes overhead in April. And so I think that might be an event where we can use to talk about the fact that we are understanding these things, we are tracking them, and we are taking action.
Thank you very much. And Don't Look Up, the film, also included the scenario of a mad tech billionaire trying to stop the asteroid being deflected because of the rich mining potential of the asteroid. I think what you're saying, there is that that is unlikely for commercial reasons for some time to come.
I would say so.
Yes, let's hope I'm right.
No examples of that potentially spring to mind. Thank you so much. Just before we finish this session, I just wanted to ask you, each of you, if you could say what your top 3 asks of the UK government, or other governments.
No, keep going. I have a question just after yours.
We're coming to the end of it.
It's related in terms of funding. So in addition to your top 3 asks of funding, how do you, this is kind of your pitch. Obviously, we have increased science funding, but there is still a limited amount. Why should it go to something that has such a small probability of happening versus something like climate change research, which we definitely know is affecting people today?
Great. So what would be your top 3 asks of the UK government in terms of resources, support, or facilitation? So it doesn't necessarily have to involve money. And why should we focus on that and not other demands on public purse and attention? So I'm going to start with Chris and then go to Dr. Sarah.
I think I have 2. So one is, I think, it was clear from the YR4 example that the astronomy coordination worked well. I'm less sure about coordination amongst space agencies. So I'd like to see the UKSA, and I know you've got a panel on this coming up, taking a leading role in coordinating, thinking about missions and responses to if we find an asteroid. And I think funding, of course, but I think particularly for early career researchers who want to work in this field, because as you've heard, we need long-term monitoring. Projects like Vera Rubin last 10 years at least. And I think dedicated funding which would help early career researchers invest in making this part of their research portfolio would be really helpful. Why this and not climate change? Well, one, I think it's very difficult to leverage different areas of science against each other, but I will point out the crossover. This is an investment in technology, it's investment in processing, it's an investment in machine learning and AI, it's an investment in how we use the supercomputers to predict things and lab facilities. So I think that I would always favour interdisciplinary areas because they have the potential to affect many different parts of the scientific portfolio and many different risks that we face.
Great. And Dr. Sarah Crowther?
Well, I think I would add to what Chris has just said, and about the long-term nature of funding, because some of these missions, from inception to planning to the mission launching, collecting the samples and bringing it back, can be somebody's whole career. And yet, if you've got early career researchers on 3-year funding, they can't play a part in that in full. And also, the UK's funding is kind of a bit disjointed in this area. So astronomers like Chris and planetary scientists like me are funded through STFC, the Science, Technology and Facilities Council, generally speaking. But the people looking at things like the orbital dynamics and the engineers are funded through EPSRC, Engineering and Physical Science Research Council. So you've got people working on different aspects of the same project, but who are through two completely different funding sources, which makes it rather disjointed. And then there's no dedicated support for people involved with asteroid missions. So the UKSA has calls for people involved with planetary missions, but there's no dedicated support for people involved with the asteroid missions. And the funding cycles of, let's say, STFC don't necessarily coincide with the timescale of a mission. So they don't necessarily match up. So if there could be funding dedicated to people involved with the missions, I think that could make a big difference.
Great.
And to add to the points relating it to climate change, again, I'd say, it's really hard to pit one against the other. And as Chris said, technology advances in one area can benefit another area. But I did read something on the train yesterday that was comparing the risk of asteroids to the risk of fire, a house fire. So the chance of having a house fire is quite small, but you buy home insurance because the cost of that is quite small. The risk of an asteroid hitting is quite small, but the potential consequences could be significant. The relative cost is smallish, and there's no point saving that money if there's going to be a catastrophic impact that basically wipes out most of humanity and there's no one left to spend that money. And I thought that was quite a nice way to look at it.
Okay, well, we've started with the potential catastrophic impact on humanity, and we've come back to that at the end. But thank you so much for you. It's been your contributions. It's been a fascinating discussion. We really appreciate your time, and we will continue this in a few moments with the next panel. But for the moment, order. Thanks. Three, two, one. Order. and welcome to this, the second session in the Science Committee's investigations into asteroids and their potential impact. And I'm going to ask Kit to kick us off with our panel.
Thanks very much indeed. Thanks for coming. If you could, in answer to the first question, just introduce yourself, that'd be helpful for our viewers. We've had some reassurance from our first panel around probability of us all being wiped out by an interstellar object, and we've kind of been through the probabilities and the surveillance and the measuring, but I wanted to ask you some questions about what, if anything, we might be able to do about it if one of these things comes slinging through the universe towards us. And so I guess my first question to you is what does our own effort and our international collaboration look like? And in particular, are we participating in the DART programme?
I'm happy to kick off first with an introduction. So my name's Edward Baker. I work at I'm the Programme and Planetary Defence Lead at the UK Space Agency and the National Space Operations Centre. I'll quickly just make a distinction.
Sorry, what was your job title?
Programme and Planetary Defence Lead.
When you tell people in the pub that's your job?
Yeah. it impresses people, yeah. Yeah, it is a cool job title. But just to give a little bit of a background on what NSPOC is, National Space Operations Centre, it's a joint civil-military organisation in partnership with the Met Office. So the staffing is made up of UK Space Agency and UK Space Command. We coordinate and combine UK civil and military space domain awareness capabilities in order to enable operations, promote prosperity, and protect UK interests in space and Earth from space-based hazards, threats, and risks. And our involvement in planetary defence has taken place over the last year. So NSPOC was formed in May 2024, and at the start of that we didn't have a UK planetary defence alert capability, but over the year we have developed that. It was launched in October 2024, and in January 2025 the UK Space Agency joined the International Asteroid Warning Network, or IWAN. That actually took place 7 days before the first global alert for YR4 was released, so it was good timing on my part. And we're also a member of the Space Mission Planning Advisory Group, which is the two UN facilitated organisations that are dedicated to planetary defence. IWAN is focused on detection, tracking and characterisation, and sending out a global alert if a threat is identified, whereas Same Page is focused on the planning of reconnaissance and mitigation space-based missions if a credible threat is identified. I can go into a bit more detail about what they define as a credible threat later. Or...
Come on to that in a bit. Yeah.
Sure.
So sorry, Dr.
Okay, as an introduction, I'm Sihira Pitam, based at the University of Edinburgh. I'm a reader there, and I'm working on generally small bodies of the solar system, like comets and asteroids, and trying to understand what they're made of and what tells us about the history of the solar system, basically. And I was involved with the DART mission, mostly from a point of view of watching the effect of it from the ground, like what did that do? So maybe in terms of contribution to the UK, to missions, what are we involved with?
It might be worth, just before you do that, Doctor, is perhaps for our viewers, you could explain just briefly what the DART programme was.
Yes. So, well, your question earlier was about what can we do if we find an asteroid that's coming towards us, right? It's a very good question. Well, there are different options. One that's easy one, if we find it fairly early in fairly late notice. Well, and if it's the city killer size, let's say you just evacuate, that could be an option, right? It's like civil defense, you just evacuate. If you find them longer in advance, you've got a bit more option of what to do. And one of those options, it's what's called kinetic impactor. It's basically playing pinball and just hit the asteroid and you deflect it out of its trajectory. You just nudge it slightly off, and if you do it long enough in advance, it has enough effect to pass us by, basically. And that's what DART was. It was a demonstrator of that technology of kinetic impactor. So the DART mission in September of 2022 impacted a small asteroid called Dimorphos, about 150 meters across. And so this asteroid Dimorphos was a very interesting one in the sense that it was part of binary system. So you had a small asteroid that was rotating around the big one. And the reason they picked that one is that it was, when it was passing in front, it blocked some of the light. So you see a little dip, and you can see how often that happens, and so you can determine its orbit around the big one. And what we could see is we could see the change before and after. So we could see how much we changed the orbit of this asteroid with the mission. So that was critical to see how efficient, not only, well, did it work, but how efficient is it? And so that's what DART did in 2022. And I think
So just a couple of questions about that. So how far away was the asteroid? How long did it take the spacecraft to get there?
I think
basically, they just smashed the whole thing into it.
Yes. So it took about a year. I'm terrible at numbers, so I don't remember the exact distance, but it took about a year to get there with the spacecraft. So it was far away enough that it didn't pose any risk, right? There was no risk of it getting nudged towards the Earth and cause a catastrophe. So it basically, the spacecraft didn't survive. So the spacecraft, it didn't release, mass or something to the asteroid. The spacecraft was crashed. What happened? It had a few CubeSat that it released before that provided images immediately after the impact that let us see, from nearby what it looked like, and then the rest of it we audit from the ground. So that's where the combination of the space mission itself and all the support and international collaboration from the ground was absolutely essential to know how efficient it was. So I think, if I remember well, the mission has a requirement of changing the orbit of the asteroid by 7 minutes, and it changed it by 32. So it was very, very efficient. And that tells us a lot about, for example, what the asteroids are made of. So it just how efficient that technique is for that type of asteroids. And so there was UK collaboration for that. The mission was led by NASA, and there wasn't any really funded effort in the UK, but there were a lot of individual scientists like myself who got involved, like either modeling the impact ejector. There's a huge expertise in the UK for that, particularly in Liverpool, or just observing the effect of it for those of us who are observers. And I can tell you a bit more about the campaigns if you're interested.
Just before we get to that, I just want to ask, and I've got some more questions for you, just what you said, but just before we get to that, a year away, a spacecraft, so we're talking tens of thousands of miles away.
Yes.
And this thing was 150 meters across.
Yes.
How accurately did we hit it? What was the probability of us missing?
So I don't know if we had really a probability. So the thing is, we didn't just launch it and just let it follow the trajectory. There was an autonomous navigation system that really locked into the asteroid and corrected the trajectory without us. So for the last moments of it, and the last day or so, there was no, alteration of the trajectory sensed from Earth. It was all autonomous navigation. So it's not only a feat in terms of planetary defense and demonstrating the technique works, but it's also technologically, it's demonstrating that ability to do autonomous navigation near a body like an asteroid.
Right, so it was a self-guiding missile,
Yes.
effectively.
Yeah.
That could make us right.
Very cleverly made, because you approach it and you needed to be able to say, oh, that's the big one, that's not the one I want the small one, and then center on it and keep going. It was very nerve-wracking watching it live.
Just out of interest, Chair, if you go on the DART programme website, you can watch a video of the last moments of the missile before it hits the asteroid, and see it closing. It's extraordinary that they were able to do that.
Yeah, it's the only time where it becomes all red or all black, and that's usually not what you want to do for a space mission. But there, everyone is happy because it made success. It hit.
And what is the successor to DART? Are they going to try a bigger, better? Because moving it by 32 minutes may not be enough deviation, presumably, for something that's bigger that might be coming towards us.
Yeah, no, it's the successor in a way would be the Hera mission, which is sort of the European counterpart to DART. And that's undergoing the sort of crash scene investigation. It's going to arrive in 2026 and going to kind of see what's happening. and how this affected the asteroid. What's left of it, is there a crater, or did it all get remodeled to have no sign of it? So it's going to be very, very interesting seeing how the asteroid reacted to it. It's going to tell us a lot about what it is. So in terms of other, and again for HERA, there's UK involvement in terms of science team. There's even UK leadership for some working group, but not formal UK involvement. So a lot of the researchers there are doing on their own research time and very limited resources even to attend to conferences.
Okay, so and just a final question to Edward, sorry. This new organisation that you've established in the last 12 months or so, we didn't have that kind of capability before. What was the decision-making process for its creation?
I can't go into the details of what led to the creation of the National Space Operations Centre. I believe it was just the desire to combine civil and military mission sets to do with space. But it isn't to say we didn't have some of those capabilities beforehand. So with, for example, severe space weather, that's led by the Met Office. But before the establishment of NSPOC, there was a space surveillance and tracking team within the UK Space Agency, and that was the team I was a part of beforehand. And our responsibility, again, which we also do now, is to provide alerts, reporting on, and to monitor activity in the space domain and report on risks such as provide services for collision avoidance between satellites, reporting on satellites or rocket bodies that fragment in Earth orbit, those uncontrolled re-entries as well of satellites and rocket bodies, and also doing launch notifications. So, for example, earlier this year, the Starship breakup over the Turks and Caicos Islands, we were leading on the reporting for that as well. So it was more just kind of bringing together all these different capabilities. And when NSPOC was formed, it was more that I noticed that there was a capability gap. We weren't really doing anything on the reporting side, the alerting side for planetary defence, and I felt that we should, because it seemed like the right thing to do, and to bring us into line with what loads of other countries are doing, not just the very large space agencies like NASA or the multinational organisation like European Space Agency, but also the national space agencies of France, Italy, Germany, Japan, South Korea and China.
So on that, thanks very much. On that, in terms of what other nations are doing and what we are doing or planning to do, would you say that we have a plan for planetary defence?
So I think it's that and how prepared we are. I think you can break it down. So on the alerting side, I think the UK has quite...
Well, you can break it down, but do we have a plan? Is there a document somewhere that says we'll do that? Or are we relying on the global planning to tell us what to do?
We're relying on, well, not tell us what to do, but how to coordinate that response. So yeah, the two organisations which I've mentioned are facilitated by the United Nations, I1 and SamePage. They cover the requirements that for detecting the asteroid, for characterising its threat, for sending out that alert to the United Nations General Assembly, and then if the risk is credible enough, and so SamePage, the threshold they have is the asteroid has to be over 50 metres or estimated to be over 50 metres and have over a 1% chance of hitting the Earth within the next 50 years. When that happens, SamePage's members gather together to collate and figure out what a reconnaissance mission to study the asteroid and what a potential mitigation mission should be, and then that is presented to the United Nations Committee for the Peaceful Uses of Outer Space, or COPUOS, for them to make that decision. So these organisations will find the threat and provide a recommendation on what to do, and then it's really up to the global community to decide what the response should be.
Does the UK have in place the resources and the ability to respond, the hardware, whatever it is that we need to play our role in responding?
We've only recently started the engagement with the UK Space Agency with the academic community, so I'm not really in a position to say yes or no. But we are building an academic network. We are starting to bring together academia and the space sector into the delegations of SamePage and I1, so that if there is a credible threat, they're involved in the work in that, as well as the work taking place before that on training, exercising.
So do we have an idea of what the sort of what we might be asked to do? I mean, can you give an example of what the UK might be asked to do in response to a 100-metre asteroid which was going to hit the UK, hit the Earth in 5 years?
Not particularly. No, I wouldn't be able to say. I mean, so SamePage does run exercises, which again looking for a scenario to work through and to figure out what the reconnaissance and space-based mitigation mission might look like. Some UK academics have had involvement in that, but this hasn't been facilitated by the UK Space Agency. We haven't been involved in that, so I wouldn't.
Right.
Because our work on this is relatively new.
So the UK Space Agency isn't involved in planetary defence.
I wouldn't say that.
Oh, sorry. I thought you just did say that.
So we're starting to take more of an interest in planetary defence, but it hasn't been a risk. It hasn't really been before.
Right. And is the asteroid threat on the National Risk Register?
No, it isn't on the National Risk Register. So it was considered for the NSRA between 2019 and 2021, but the scenario that was presented didn't meet the criteria for inclusion. I don't know the ins and outs of the scenario that was presented because I wasn't involved in that, but I believe it was rejected primarily on the basis that it was submitted as 1 in 200,000 probability, which didn't meet the criteria for inclusion.
Can I maybe just comment on what Ed just said there about scenarios that are being played out? So there's SamePage that I mentioned prepares scenario, and there's this conference that's happening every 2 years. That's called the Planetary Defense Conference, and it's basically a giant role play. Well, not all of it. There's conference with talks about planetary defense and latest techniques, latest observations.
Conference.
Yes.
Oh, cool.
And it gets better. So they run a giant scenario. So, we discover an asteroid and it's en route to the Earth. And what do we do? So they play out the entire scenario from it's discovered, we characterize it, but it's not only an academic conference. The main point of it is that it brings people from space agencies, but also people from governments to work out internationally a response to a potential threat. And that's, I think, John, what Ed was saying, that academics in the UK have been participating to that conference. But I don't think there's been official UK government involvement to this exercise in the way that some of the other countries have engaged in it.
That seems rather concerning. I mean, although we spoke earlier about how it is a high risk, though low probability, it would seem that it was something that the government should certainly be aware of and engaging with actively. And do we know what the UK Space Agency spends in terms of this on planetary defence and asteroid tracking?
So I can speak from the point of view of the National Space Operations Centre. We haven't directed any funding to planetary defence. The work that we've achieved has all been under just the regular work that we do. The UK does invest into the European Space Agency's space safety programme, so we have had a minor involvement in the ground-based telescope FlyEye, which is now operational in Matera, Italy. And we have some additional small returns coming from HERA. But there is an opportunity for the UK to be involved in the upcoming Ramses mission, which is going to study the asteroid Apophis in 2029. That is depending on the level of funding that DSIT allocates to that. But there hasn't been any direct funding to planetary defence from the UK Space Agency in, I would say, the last 10 years.
Right. Has there been indirect funding through the European Space Agency?
Well, I'm not entirely sure on that. Kind of going back maybe 25 years. So the topic of planetary defence was raised in the House of Lords in 1999. And one of the recommendations from that was a task force, which made a series of recommendations for UK government, most of which weren't implemented. There was some funding, I believe, for a UK Neo-Information Centre, but I don't know I know the current status of that funding hasn't been in place for a number of years. Yeah.
Maybe to add to what you were saying, so there's elective parts to the ESA program that are, for example, HERA mission, where not all, so you have the parts where all countries have to contribute, and those that are elective. And in terms of what concerns planetary defense, the UK has generally elected not to participate in it. So that's the case for the HERA mission, where I think there's a little bit, I don't know exactly what it goes to, but there's no formal involvement in the way that UK could lead instruments. But it has the technical capability too. It has the academic supporting it as well, but without commitment from the UK, say that's not possible, basically.
I think following this this session, I think the committee would be very interested to understand what funding we are making available for planetary defence and why. Kip, did you?
No, I was.
Great. Okay. Now I'll ask John to lead us off on policy and governance.
Welcome both. Before I get on to internal sort of UK governance and policy responses, can I just ask, in terms of what you've just been talking about, how is the international decision made in terms of planetary defence? So who would make the decision on what the reaction was? Is it a specific body? Is it effectively who has the technology? How would that, in your role playing at these conferences, who are the decision makers?
For example, in the exercise that I attended, hosted by NASA and the Federal Emergency Management Agency last year, and the experience that I've had in some of the other workshops, these decision makers are the heads of governments, the heads of these space agencies. That is coordinated by the United Nations. I think it's really who has the capacity and the technology and the money to fund these missions. I suspect, NASA and ESA and increasingly China are taking an interest in planetary defense. I think a lot of the coordination would be done by NASA, ESA, China. They have whole teams dedicated to planetary defense. I suspect they would be leading that charge mostly.
Yeah, I think I would agree. It would be a lot done by agencies, space agencies, and probably through the UN. I think the UN is playing a lot of role in setting these bodies are on the same page, and I think through the UN Security Council probably would play a role in the decision.
But there's been no, given how important it would be to make the right call, and there may be lots of differing views, there's no legal framework or agreement on the decision-making sort of protocol for what the response would be.
No, but SamePage does have a legal working group whose purpose is to work through some of these policy questions. So I think this is being considered, but the membership of SamePage is made up of space agencies. These aren't necessarily the absolute decision makers. I wouldn't be able to comment.
We need to move on because we're running out of time. Unfortunately, this is
very interesting. I'm grateful for that. So, looking then specifically at the UK, if that's okay, how would you, how well prepared would you say the UK would be to respond to an asteroid impact? Do we have policy protocols? Have we run through scenarios, simulations? Again, that decision-making process of what happens, or would it be a case of once threat was identified that we would then start going through that process, or are we already a long way down that line?
I would say the alert procedures are firmly in place, and the interfaces that we have with all the organisations of I1 and SamePage are well established. But we haven't done, there hasn't been an exercise looking into how the decision makers would go about making that decision. That hasn't taken place. NSPOC did host a small-scale walkthrough exercise, testing our alert procedures earlier this year before 2024 YR4. There hasn't been an exercise looking into what the response would be and how the government structure would go about that. I think it's worth noting that whilst this isn't work the UKSA and the UK government has done, but there has been considerable work looking into what the effects of an asteroid impact would be, and do governments have the national frameworks in place that could be tailored and adjusted to deal with that? So the US has done a lot of extensive work on that, and broadly the result is that frameworks for natural disasters can be tailored and adjusted to meet the requirements of what the effect of an asteroid impact would be. I think, going back to the NSRA, whilst it was primarily rejected on the grounds of its probability being 1 in 200,000, I think there was also an understanding that many of the effects, again, we would see from an asteroid impact were already covered by other risks in the NSRA. So it's the whole point of this is not to duplicate work. It's just I think it's to understand what we already have in place that can be adjusted for the risk. But it's also worth saying that as a member of the European Space Agency and its fourth largest contributor, I believe, we do get a lot of returns from ESA for planetary defense. A really interesting tool which I wanted to highlight was the Impact Visualizer tool. So I have been sent some graphics just to show, for example, if 2024 had impacted the UK, if that had been a scenario, ESA would very quickly be able to tell us exactly where that impact would be and what the effects would be, and put that on a map. And that's very useful for first responders. It's very useful for decision makers. You can overlay critical national infrastructure sites, because critical national infrastructure is, again, one of the areas the US has looked into, and they've come to that same conclusion that the current frameworks in place can be adjusted and can be tailored. And I think some light work in European Space Agency has gone on in this area as well. So I'm happy to share these graphics around.
Okay.
Like that? Okay, no.
Well, we'll study them, but thank you very much. It's very useful to know that we have graphics of the impacts.
Sorry, Dr.
Just maybe a note of something that might not have been considered in the past, and I think Professor Lintop mentioned earlier, is the impact to assets as well. As new models have shown for YR4, if it hits the moon, it might have an impact, well, not on Earth, well, might have a spectacular meteor shower, which would be pretty, but that would also mean an impact on satellites on low Earth orbits, for example, Starlink satellite, which would get as much. So you have an impact of small particles in space all the time, but you get the equivalent of 10 years potentially of that within only a few days. So it's not only the impact it can have here, but on us UK potentially assets in space as well that needs to be considered.
Okay, thank you.
And just to be clear, we're not an outlier then in terms of our planning and our response to a potential. We're consistent with the US, with the other EU countries, and so.
Well, we don't rank, obviously, the US in terms of scale and scope far exceeds the UK, but I think within Europe and the global community, I think we're a valued and trusted partner on planetary defense. We take the risk, seriously in terms of the alert capability that we've established. We're one of 14 space agencies who are a member of Same Page. So by virtue of that and our membership to I1, as well as we co-sponsored the UN resolution to designate 2029 the International Year of Asteroid Awareness and Planetary Defense. So, on the advocacy front as well, it is a risk we are, and I think amongst our peers, we do fare well.
Thanks very much, Jan. Can I just the National Audit Office report, the National Space Strategy and the role of the UK Space Agency, stated that the UK does not yet receive contracts from the European Space Agency proportionate to the value of the funding that the UK's Space Agency gives to the European Space Agency. And you said we're one of the largest funders. Do you think that lack of return is impacting our engagement on planetary defence with the European Space Agency?
So I'm not involved in the investments that go into ESA via the UK. That's managed by another team in the UK Space Agency. So I'm not involved in that process. So I don't think I'd be able to comment, but happily write to the committee afterwards. Okay. I represent the operational side of what National Space Operations Centre does for planetary defence.
But I just wondered if that was impacting our readiness to put more into the European Space Agency when it comes, generally and particularly when it comes to the planetary defence. But if you can write to us on that, if you're not in a position to comment. Now, Lauren, should we turn to? We've got about. Do you have a hard stop at 11? So we can go a few minutes over, but we'll go with Lauren.
Oh, lovely, thank you. So I wanted to ask a little bit about the DART project and whether there has been further spin-outs or further information and education that we've learned from that whole exercise.
There's probably been a lot of impact from all of that worldwide. One of them would being education. Right? It's something that's one of the advantage of planetary defense. It's that it's incredibly easy to engage the public in, right? There were comparison earlier with climate change. It's very easy to convince people of the risk, let's not be like the dinosaurs. It's really, really good way to engage. People are immediately interested, particularly kids. So there was a lot of public engagement by UK team that have been done here in the UK. And so it's a very, very good way to engage people in STEP subjects in that way. So I might talk about personal experience of unintended consequences that participating in these projects can have. So I was personally involved in a project to put a telescope in Kenya to observe the DART impact, because at the time where it happened, it was located above the Indian Ocean, meaning that all the great telescope that we've used in Chile to look at it a bit after could only catch it, I think, 6 hours after the impact. And so the only sort of professional observatory that could catch it at the time was South Africa. And it's always like if you relied on one single place, it's going to be cloudy there. That's the limit of astronomy. So we got some funding from the University of Edinburgh and installed a very small telescope, 40-centimeter telescope, in the northern part of Kenya. And we successfully observed the impact. We engaged with the Kenyan Space Agency there that were there, came to the location where we installed the telescope, were there at the moment of the impact. It had a lot of publicity here and around Kenya. And so we've kept engagement going on with the Kenyan Space Agency that is also interested in planetary defense. And further on, that we use this facility to engage with a project called DARA, which is aimed at the driving development in Africa using astronomy. And so we're now using that telescope to train 60 African students a year from 8 different countries in astronomy. Some of these students have gone on to work for the Kenyan Space Agency. Some have gone for the work for pretty high position in the International Astronomical Union. So really creating these skills in African countries using this. So that has had very unintended consequences, which are direct impact on real life. That came from not much. I think we got about 15K worth of funding from the University of Edinburgh. That has an impact that's going to last for years. So it's not always about having a lot of funding for things. Even small amount of fundings can have a lot of impact, because those are subjects where it's easy to engage people in and bring them and impart skills using that as a base.
Interesting. I wonder if you wrote that on the impact assessment when you applied for the grant.
It's coming in the next ref. It will be there.
This is it. It's difficult when you're applying for funding.
Yes.
You're supposed to give all of the potential impacts, and sometimes there are these wonderful impacts that are unforeseen. So it's take that back. No, thank you. Just sort of looking ahead at when you were saying about engaging with children and youngsters, and like the idea of mining asteroids, and I've seen many diagrams drawn about how they can do that. I mean, I know from the early panel we're a long way off from that, but in terms of like the regulation and just sort of like how on earth, what do we need to be considering to make this a reality? And that's to both of you.
Yes, I think in the short to medium term, it's likely that all the space resource activities will take place in situ to support further space-based activities. In the longer term, it is possible, and it is something that the UK can look at. While we don't necessarily see a commercial viable model for the extraction of space resources and return them to the Earth for sale, in the short term, it doesn't preclude UK companies looking into this, collecting data, prospecting data, and conducting small-scale demonstration missions. Internationally, the United Kingdom has taken the view that international discussions should focus on the principles of in situ resource use and extraction first, with more future-focused space resource issues such as commercial return to Earth of space resources for sale.
So for in situ, can you just expand on what you mean by in situ?
Currently in place, so like not disturbing it. Where is that correct?
Yeah. So basically, that could be you go there and you mine water to make space fuel, or
yeah, exactly.
For rockets, you don't bring it back.
You don't extract something and bring it back to Earth.
No.
But yeah, so this doesn't preclude states or national space agencies from benefiting from these commercial arrangements in place, whether it's to support scientific investigation or commerce. Yeah.
Maybe you can comment further on this. So there's very little legal framework. I think Professor Linton mentioned it earlier. Basically, what's still the main regulation, that's still the Outer Space Treaty from the late 60s, if my memory is correct. So that's really not very appropriate to what's happening now. And there's a lot of fuzziness, because you can't own the asteroid, right? You can claim an asteroid, and you can prevent other people from accessing it. But like if you get mining station on asteroids, like how do you say if multiple people wants to mine the same asteroid? Like you can easily enter conflict situation if there's no regulation. And I think there's something where the UK could potentially have an impact. There are degrees in space laws now in the UK, so we have people that are ready to work on this kind of subject, and UK has a lot of soft power, so could have sort of paved the way in terms of legislation of how to do it, because there's not only the considerations of avoiding conflict, but there's also ethical consideration. Professor Leighton was mentioning the risk of crushing the economy for these rare earth metal, but it's also the impact of thinking of the impact of those countries that are currently mining the minerals, like countries in the global south, whose economies heavily rely on these minerals and are the ones that don't have the capacity to take part in that. So how do you make it fair if you're using resources that have to be used for the benefits of all, or do you make it fair for all countries? Or do you make sure that it's sustainable, that it doesn't harm the environment more than it brings in? So there's a lot of question that need to be worked on, where UK could use its soft power to really lead the way, obviously in collaboration with the United Nations bodies that are looking into that.
Yeah, brilliant. Thank you.
I wasn't aware we had degrees in space law. Which
I can't remember where it is. I think I've seen that somewhere.
They just come up with cool stuff all the time. I've got a degree in space law.
We do have people in Edinburgh working on space law. So that is this is something.
I thought you made a very good case for the UK using its soft power, as it were, to make progress in the area. And one of our inquiries is that we're launching soon is on science diplomacy. But do you think right now that the UK is doing enough on that? And should it be something that, for example, the committee should request?
I'm not really involved in the regulatory side of the UK Space Agency.
I think I'm not entirely sure why exactly it's being done. I think it's being done a lot by individuals. So I think they are individual, as far as I'm aware.
Right. So there's no coordinated action by the government to help bring space law up to date.
Like our academic universities are across the globe already.
Getting there
already. Right.
So
it was a recommendation from a report from the Regulatory Horizon Council that came out last year to contribute to the space regulation in the UK. So work with the United Nations to build those space laws.
Well, I would just like to say that the UK Space Agency does send delegates to United Nations Committee for the Peaceful Uses of Outer Space in Vienna, and we do engage with international partners, highlighting good practices and working with partners to ensure space activity remains peaceful, safe and sustainable for all humankind. Some of the discussions focusing on norms of use for the moon and other celestial bodies. So we are involved. We do regularly engage with the United Nations on this.
I think maybe a last point, sorry, I forgot to mention this, that some countries are delivering mining licenses already. There are 3 countries that have delivered mining licenses for asteroids, so that have a framework to do that, which are Luxembourg, who was the first one to do that. So it has attracted a lot of venture capitalists through that, and the United States and the UAE. So
the United States and the UAE have given mining licenses for asteroids.
Some countries have, delivering.
Right.
Like identified asteroids that they've claimed are their own.
I'm not aware of the detail. I know that those countries are.
Okay. Well, I think we'll want to understand that better. And just final question to each of you. And you may have answered this question already. But so what is your top asks of the UK government or any other government in terms of supporting facilitation for planetary defence research and practice?
So for the National Space Operations Centre, I see my top ask or the requirement or the urgent need is to bring the academic community and the sector into the delegations of Same Page and I1 to ensure that they're contributing to the work that they're doing and to ensure the UK's reputation as in planetary defence remains strong. So that would be my top ask.
Fantastic. And Dr. Upton?
Most of them will be funding in general. Well, one thing that could be done without even requiring funding is there will be a ESA ministerial where they're going to make the decision on whether the Ramses mission, so the next next step in planetary defense happens. UK support for that would be very, very welcome by the community, just to make sure that the mission happens at all. Then in terms of funding, I think there's mentioned before, but even a little bit of funding is useful if only to organize the community, to have meetings within the UK or to allow people to travel. So a lot of people that have been involved on their time. I was lucky enough to get involved because I'm on a fellowship from the Royal Society and I have a lot of academic freedom and funding, but even freedom to funding to travel to conferences to present the work that they're doing is already making a difference. Particularly because, as was mentioned before, the communities are a bit silos and depend from different councils, which sometimes make it hard to have a continuity and long-term view of it. And we're at the moment seriously at risk of losing some critical expertise. So there are fields of expertise like radar observations of asteroids that are essential to get their shapes and some of their orbits, or some study of their non-gravitational forces, where we're at risk of, we were really at the top of the field in the UK, but we are at risk of losing people because there's no funding priority for this. And so it's really difficult when people naturally retire to keep these expertise within the UK. So a consistent way of getting funding, whether it is through UKSA in an innovative way so that people can participate to space mission and potentially have hardware contribution to the UK would be very welcome. And I think a last point is that in terms of visibility, there are conferences like the Planetary Defense Conference. The next one is happening in 2029, where Apophis is going to, so the asteroid Apophis is going to make a very close passage to the Earth. Everyone is going to have eyes on that. It's going to be visible with the naked eye at a time. So it's going to make a huge splash. And there would be an opportunity, for example, for the UK to organize the Planetary Defense Conference, or to host it at a time, which would give it a really good visibility on the international stage, and not, again, with not crazy hundreds of thousands of pounds amounts of funding, that could bring a really good visibility.
Very good, great. And Mr. Baker, would you be able to help in the organisation of that conference?
Personally, yes, happy to. I think it's a really positive, a really good idea. The UK has hosted similar conferences on other risks before, but I think it's an interesting opportunity, and it's a once in a millennium opportunity of office.
Great. So we look forward to progress. You here first in the committee. So thank you very much for your contribution. It's been an absolutely fascinating debate, and we look forward to a planetary defence plan which keeps us safe from the high risk, though low probability potential of the extinction of humankind through an asteroid. Thank you very much. Order. Excellent. Very good.